Hello, everyone. My name is Kasirzadeh. I am a philosopher and a mathematician at the University of Toronto and Australian National University. Today, I'm going to talk about a paper co-authored with my colleague Andrew Smart from Google San Francisco. Our paper is about the use and misuse of counterfactuals in ethical machine learning. Counterfactual thinking is a very popular mode of thinking about the alternatives of an actual situation. So, for example, consider the following factual statement: kangaroos have tails and they do not topple over. One way to think about an alternative of some of the alternatives of this situation is through the following counterfactual statement: if kangaroos had no tails, they would topple over. Of course, the issue of how to evaluate the truth or falsity of this counterfactual, if that's possible at all, matters very much for making sense of counterfactual statements. This is an issue that we come back to it shortly. Let's review one other example, which would be much more related to the discussions of ethical machine learning and the use of counterfactuals for ethical machine learning practice. So assume that someone captures some goings on in the world by the following factual statement: Nora is Latina and she is denied a loan. Now, one way for this person to counterfactually think about this factual situation is through the following statement: if Nora had not been Latina, she would not have been denied the loan. Again, making sense of the truth or falsity of this counterfactual statement matters very much if you want to use counterfactuals for ethical machine learning or for making sense of any other notion. This is an issue that we come back to it shortly. Now, there has been a widespread attention to counterfactuals for making machine learning systems adaptable with some ethical principles, such as fairness or transparency or explainability. And the main motivating idea behind all of these attempts is to make the notions of algorithmic fairness or algorithmic explainability, as two examples, precise. So these notions are very vague and very difficult to pin them down into some precise characterizations that, for example, can be used in legal frameworks for regulating algorithmic decision making, or can be put into some computationally tractable way or ways for designing machine learning algorithms that satisfy some counterfactual explanation or counterfactual fairness constraints. So we're going to talk about two main papers in the literature, mainly because these two papers probably to date are two of the most cited papers, and they have basically shaped very much discussions of counterfactual fairness and counterfactual explanations in the machine learning practice. What is a counterfactual explanation? Roughly speaking, a counterfactual explanation is an answer to an explanatory question in counterfactual terms. So, for example, consider the following factual statement: Nora's loan application is denied, and assume that, among other things, her annual income is $40,000. Now, one way to explain why this prediction or decision is made is as follows. If Nora's annual income had been $60,000, she would have received a loan. But as a matter of fact, her annual income is $40,000, and if this counterfactual explanation is shown to be true, then we might say that there are some counterfactual dependence relations, or some might argue causal dependence relations between Nora's annual income and the status of her loan application. Counterfactual fairness can be characterized in different ways. Here we quote a very interesting and popular definition from the literature. So counterfactual fairness captures the intuition that a decision is fair towards an individual if it is the same in an actual world and a counterfactual world where the individual belongs to a different demographic group. So consider the following factual statement. Nora is Latina and she is denied a loan. Now, a counterfactually fair decision says that the following counterfactual statement is true. If Nora had not been Latina, she would have been denied the loan. So the result of the decision is the same, no matter which demographic group Nora belongs to. Despite the fact that in many scenarios and many situations, counterfactuals are used in various interesting ways for making different notions explicit and precise, we wanted to know when is it appropriate to apply counterfactuals for making machine learning systems ethical. Because at the end of the day, many of these machine learning systems are used or will be used for making various social decision making. So they require thinking about various features that are socially there are social notions like race or gender. And so it is good to know when it is appropriate and when it is not appropriate to apply counterfactuals. When we reviewed various papers in the machine learning literature, we realized that the answer to this question is missing. And therefore, in this talk, we are going to argue for two things. First, that the use of counterfactuals for ethical machine learning is not as straightforward as we might assume. And then we discuss some conditions for applying counterfactuals to ethical machine learning by drawing on the philosophical literature. More specifically, we are going to make two sets of value judgments and presumptions explicit. These value judgments and presumptions are always necessarily made anytime we are using counterfactuals. The first set of assumptions we call ontological assumptions. The second set of assumptions we call epistemological semantic assumptions. So ontological assumptions roughly reflect all of those value judgments and presumptions that we make about the thing that we are going to assume contrary to the fact. So, for example, the fact is that Nora is Latina and she is denied a loan. A counterfactually fair decision says if Nora had not been Latina, she would have been denied a loan. Now, what does it mean to think that Nora is Latina or Nora is not Latina? Or Nora had not been Latina? Is it possible to do that or not? The answer to this question depends on whatever view you adopt about what social categories are, or the ontology of social category, in this case, the ontology of race, Latina. And anthropologists, historians, social scientists, philosophers have developed many, many different views about what these categories are. And the answer, of course, to the question is not at all easy or straightforward. And in the rest of the talk, we're going to take race as a prototypical instance of the social categories of interest to counterfactual manipulation. Also, one thing I need to clarify. In many of the examples, I talk about counterfactually fair decisions, but all of our arguments applies easily to examples of counterfactual explanations. We just wanted to be consistent throughout this 20-minute presentation. So we stick with the example of counterfactual fairness, but basically our arguments applies to the examples of counterfactual explanations as well. Also, as I said, we are going to focus on the notion of race as a prototypical instance of social categories, but with a stretch of imagination, you can adapt these arguments and the views that we are going to argue for other social categories such as gender. As said, there are many, many different views about what social categories are. We just select 3 of them, just to give a flavor or a sense of how and why the views about what social categories are, or ontological views about what social categories are, matter for the use of counterfactuals, and also how adoption of different views kind of impacts whether we can use or not use counterfactuals for ethical machine learning. So the first theory or account about what race is a simple geobiological essentialist view about race that roughly says, let's divide human into a discrete set of categories in terms of biological characters, like modern genes inherited from past generations. And if you want to determine or identify the race of a person, you just need to go to those geobiological essential features, and there is nothing to race more than the composition of these geobiological essential features. Now, another view about what race is racial skepticism. This view says that let's disregard the existence of race in a very straightforward way. There are different variants of racial skepticism. Again, this is not a talk about ontology of race. We just want to give a feeling for how this ontological views that we adopt impacts the legitimacy of the use of counterfactuals for ethical machine learning. So this view, if we adopt this view that like race does not exist, then talking about Nora being Latina or Nora not being Latina doesn't really make sense, because Latina is just a meaningless category. It doesn't exist. And so it is difficult to make sense of that in a straightforward way. Now, a third view, racial constructivism, says that race exists, but only for the purpose of fighting to abolish social and structural injustice, for social movements, for example, or affirmative action. But out of this scope, race does not exist. Again, we emphasize that we are just giving a caricature, super simple characterization of some of these views about race. But hopefully, this characterization shows that, again, what views you adopt about the ontology of race might impact whether you would be allowed to use counterfactuals for ethical machine learning. And indeed, if you use, and one very important element is that you need to make some assumptions about the ontology of race, or some people argue your perception of the ontology of race. Now, some problems, we highlight them shortly here. We come back to them a little bit later in the talk. Some problems for this ontological discussion that we have so far is that which views about social categories or perception of social categories we must adopt when we use counterfactual thinking in machine learning systems. And whose views about social categories or perception of social categories matter. So as we all know, many of the times when we want to use models or computational systems, we are required to make lots of idealized and simplifying assumptions about how things are. And these assumptions kind of are false about how things really are, but we require them in order to be able to use our mathematical or computational gadgets. So all of these assumptions and all of these simplifying or explicit tendencies for making these assumptions simple assumptions matter for the cases of the ontological views we adopt about what race is or our perception of race is. Now, a second set of assumptions are epistemological semantic assumptions. Again, remember that at the beginning of the talk, I said one very important thing that we need to do with these counterfactual statements is to evaluate the truth or falsity of them. We need to compare a counterfactual scenario with the other, with the actual state of affairs, and there are many different counterfactual scenarios in which things could be different, in which Nora had not been Latina, or Nora's annual income had been different. So whatever view we adopt here, or the kind of presumptions that we make in order to evaluate counterfactuals, again, might be motivated by some subjective perspectives about how things are. So let's go back to our example. Nora is Latina and she's denied a loan. The counterfactually fair decision in this case is if Nora had not been Latina, she would have been denied the loan. Now, the evaluation of counterfactuals, and like this counterfactual, for example, is grounded implicitly or explicitly in either of the following philosophical approaches. So we reviewed various papers that use counterfactuals for making machine learning systems explainable or fair, and we realized that whatever method is used, conceptually, philosophically speaking, either of these two approaches is the basis of that method. The first one is the close enough possible words approach, which is an approach inspired by a couple of philosophers like Stalnaker and Lewis, and some before them, and many after them. And then the main philosophical theory or approach for the evaluation of counterfactual actually is called the closest possible word approach. But as you will read in the paper, there are good reasons to assume that indeed, when we come to think about adopting this philosophical theory for practical reasons, really what we are doing is that we just think about some close enough possible words to the actual word. And the second approach is a causal modeling approach, very well known and famous in the machine learning literature. So the close enough possible words approach compares the actual word in which two events occur with the similar enough words to the actual word in which one does not occur. The first event, like Nora being Latina, doesn't occur. And if in those words, the second fact or event does not occur, then the counterfactual is considered true, otherwise it is false. The causal modeling approach, on the other hand, describes the word in terms of some random variables and their values, and the causal relation between the variables is captured by a set of structural equations. Now, I don't have time to go through the characterization of counterfactual fairness through a lens of causal modeling approach, but if you want to know more about that, please refer to this paper on counterfactual fairness. You will find a very great characterization and description of applying causal modeling approach for counterfactual fairness. Now, some problems. First, the number of counterfactual situations that are contrary to the actual state of affairs are myriad. Which criteria tells us whether a word is similar enough to the actual word or not? According to which criteria we are going to choose set A of the close enough to the actual word scenarios rather than set B. Also, there is an inherent vagueness that has been discussed very much associated with similarity between words. And the basic idea there is that at the end of the day, it is probably impossible practically to pin down a very precise notion of similarity. So the notion of similarity is inherently vague. And that's a problem for the use of the close enough to the word, to the actual word approach. Then there are different epistemic viewpoints, which might suggest different ordering of possible words or causal models. Depending on the epistemic point, we may assign different truth values to the counterfactual statement. So again, these epistemological semantic assumptions that we make impacts the evaluation, or more specifically, the evaluation of the truth or falsity of counterfactual statements. Now, so far, we have argued that the use of counterfactuals for ethical machine learning is not as straightforward as we might assume. And an apt use of counterfactuals requires bringing forth the important implicit and unspecified ontological and epistemological semantic assumptions. So, in the rest of the talk, I'm going to talk about one qualitative strategy that we suggest for making these assumptions explicit. So, as ontological presumption and judgments can be made explicit by having an interdisciplinary conversation, going through various assumptions, ontological perspectives, what are social categories, ontological choice, what ontological perspectives do we choose to adapt and why, and ontological knowledge, how do we know about the social categories, why we choose a simple social category rather than another, and then similar about epistemological semantic presumptions and judgments, similarity choices and comparison criteria. So putting all of this together, the following interdisciplinary conversation is required before counterfactually making machine learning systems ethical. We put this interdisciplinary conversation in terms of set of questions and answers and examples in a detailed table you can find in our paper. So in conclusion, there are various trades-off and value judgments essential to the use of counterfactuals for ethical machine learning. An examination of all these assumptions produces awareness about various trade-offs, value judgments, or potential harms of using or misusing counterfactuals. We introduce some strategies for specifying and reflecting on the hidden ontological and epistemological semantic assumptions through an interdisciplinary conversation. And thank you very much for your attention.